Hi, I'm Mike Stanzik and this is Digital Electronics Classroom. In this video we're going to talk about Karnaugh maps. We're going to talk about how we take a truth table and build a Karnaugh map from the truth table. And then we're going to take that Karnaugh map and write out a Boolean expression that's simplified using the Karnaugh map principles. Alright, let's get started. As you can see here, I've started out with the truth table already in place and a Karnaugh map already in place. So this is going to be truth table to Karnaugh map. Awesome, great. And so let's put in our function. So we're going to go 0, 1, 1, 0, 1, 0, 0, 1, 0, 0, 1. 0, 0, 1, 1. Great. Okay, so how do we build up the Karnaugh map? Well, first off, let's label it WX, YZ. Perfect. And so these are minterms, right? 0, 0, 0, 0. And so if you look at the row in the column that correspond to that, that's where that minterm would go. So that first 0 would go into that first slot. And then we say 0, 0, 0, 1. So I got 0, 0, look for 0, 1, and so that's going to be a 1. And then I have 0, 0, 1, 0, that's going to be a 1. And here's where it gets interesting. Because we go 0, 1, skip a column to 2, and then back to 3, so we have to skip this column and this set of 4 and put the 1 over here. So it goes 0, 1, skip to 1, and then we got 0, 0, 1, 1, which is here, 0, 0, 1, 1, and that's going to be a 0. And so I like to group these into sets of 4, and then know that I'm going to skip that third one and go 1, 2, over, and come back. So our process is kind of going here, and then to there, and then back to there, okay? Now the same thing is going to happen in the row-wise, because we have 0, 0, 0, 1, 1, 1, 1, 0. And so we're going to go first row to second row, and then we're going to go to fourth row, and then back to the third row. So that is our process in building this up. The reason why, if you have forgotten that we do it in that way in terms of going 0, 1, 3, 2, is that if we move from any row to an adjacent row, only one of the variables change. And so this one, 0, 0 to 0, 1, only X changes. 0, 1 to 1, 1, only W changes. 1, 1 to 1, 0, only X changes. And then when we do the wrap around, it's only the W changes. So that's really important for our groupings so that we can look at what stays the same and what changes and write out our simplifications from that. And so if I look at the next group of 4, and this is 1, 1, 0, 0, that allows me to write it in this second spot. 1, 1, skip, 0, 0. And then I look at the third group of 4, and remember we're going to skip on this one. So we're going to go to the fourth row, and it's going to be 1, 0, 0, 1. And that's important because that's different, right? So I make sure that I have to skip and come back there. And then we have our last group of 4, and it's 0, 0, 1, 1. Sometimes if you made the mistake, it wouldn't matter, but we want to make sure that we're doing this correctly. So that is the main idea of this video, is that we are able to build up a build up a Karnaugh map properly from a truth table. And so now let's finish this up and do this as an example of a Karnaugh map solution. And so I'm looking for these groups of 2 or 4. Ooh, this doesn't simplify super easily. That's okay. Got a lot of terms here, and that's, I think, the best that we can do. Okay, so we have F equals, and I'm just going to start at the top and go down to the bottom. So this one, we got Y naught Z in that column, and the thing that stays the same here is W naught, so it's W naught, Y naught, Z. And then we have this singleton here, which means it's just going to be a min term, and so this is going to be 0, 0, 1, 0. So W naught, Y naught, W naught, X naught, Y, Z naught. And then we have this grouping of 2, and so that's in row 0, 1, and the thing that stays the same here is y being a 0. So 0, 1, 0. Then we got this group of 2, which is in row 1, 1, and the thing that stays in here, the same here is y is a 1, so we got wx, y. And then we got this group vertical of 2, which is 1, 1, and yz, and the thing that stays the same here is w, it's wyz. And then we got this singleton in the corner here, which is 1, 0, 0, 0, so we got wx, yz, 1, 0, 0, 0. And that would be our final expression. So we go truth table to the Karnaugh map and then to the Boolean expression, as simplified as we can get it from this functionality. Okay. Thanks for watching. I hope you found value in that. I'm Mike Stanzik. This is Digital Electronics Classroom. Make sure you follow, like, and subscribe, and have a great day.